Hi there. Welcome to Terraform Infrastructure as Code, Best Practices and Common Mistakes. My name is Derek Ashmore. I'm from Asperitas Consulting in Chicago. Basically, we escort Fortune 2000 companies to the cloud, implement hybrid cloud connectivity, as well as escort applications upstairs. I am a professional geek. I've been around doing geek stuff since 1987, which puts me at old but not quite ancient. I've been in the cloud since 2010. I've been in Terraform since the 0.5 days. My specialties are application transformation and infrastructure automation and anything DevOps. And that's enough about me. This slide deck was uploaded to the site. It's also on my SlideShare. You can get it from either place, sample codes on the GitHub. This presentation has active hyperlinks. No reason to write down URLs or anything along those lines. Just as a base, this isn't a Terraform, intro to Terraform kind of talk. I'm going to assume that you have at least played with Terraform at some point in your past. You know what it is and what its basic functionality is. Finally, keep track of your questions because we'll do some Q&A at the end. Agenda. First of all, I'm going to intro and level set. If you're here for ground level best practices and mistakes, don't worry about that. I've got 2 slides for level setting, and then we are going to hit ground zero and geek out later in the program. We're going to talk about environment management heavily, project structure. We're going to talk about modularity, how to make your Terraform more reusable and easier to consume from a module perspective. And then we're going to do some summary and Q&A. All right, slide 1 of level setting. Terminology. Terraform resources are basically creatures that controls what typically is a cloud asset. For instance, on the AWS side, you have resources that define VPCs, that define subnets, that establish instances. On the Azure side, you have resources that establish VNets, establish subnets, and establish virtual machines. And those are just examples. Data lookups, basically, they look up items that are not going to be created in your Terraform, but exist already, either through a manual process or through another Terraform configuration. They're basically a lookup tool. Variables. Variables is a creature that we use to customize a Terraform automation so they can be used in different regions or different environments. That we can use variables to supply different values per context. And along with that, there's a rich library of Terraform functions and expressions that can manipulate data items for specific purposes. That should all be relatively known to you already. Configuration versus module. This is important. I refer to a Terraform configuration in my mind is the outer level Terraform. All right. It's not called by other Terraform projects. It basically is the master. It might use Terraform modules to do more specific things and might include them. But the Terraform configuration really is the outer layer. TFRs files, basically those are properties files that can be used to supply values for variables. And typically you'll have TFRs files per environment or environment region combination. How Terraform works, it's declarative. It's not like a procedural scripting resource like Python is or something along those lines, or a bash script. It's declarative. Basically, you put in Terraform code what you want your infrastructure to look like, and Terraform figures out the mechanics of getting it there. It sucks in all files with a TF extension, and it figures out the execution order. It doesn't matter which order that you list your resources in your code, or basically it'll figure out how to do it. Supports variables and functions. I've got example resources on the upper right that illustrate use of variables in the first resource, and in the second resource I've got a use referring to they're not really variables, but they're attributes on a second resource. And those should be concepts that are probably familiar to you. There's a data lookup and an output example in the bottom right. Terraform also has a plugin architecture that lets it provide services for several clouds and several products. All right, that's the level set. Let's get into environment management. But before we do that, let's talk about a sensible Terraform project structure. All right. In the upper right, I've got a structure that my team uses for just about every Terraform project that they create. I create. Basically, the first thing to note is it separates Terraform configurations, the outer layer, from modules. All right, so in this example, AppFred, my network and security policy configurations are all run separately. AppFred obviously requires a network infrastructure before it can be run, but I don't try to connect the configurations in any way. Reusable code or reusable Terraform modules is separated out. In the beginning, it gets separated out into a local modules folder, but as you get advanced, you may see a reason to break those out into separate repositories or actually implement the Terraform registry. Under each configuration, we have TFVARS files. They provide environment specifics. In the example in the middle right, I've got a dev environment, a production environment, a UAT environment, and a sandbox environment. And examples of how you would actually use those TFVARs are in the lower right. The other thing I would add is typically we've got different backend state files for each of the different environments. Don't use the default, which is local state and stored on your laptop. Backend state we consider necessary from the very beginning. All right. A couple of our customers have started out with Terraform before we got there and implemented this kind of structure. And there are reasons for it. Initially, HashiCorp itself was suggesting this structure, but these days we consider it an anti-pattern. Basically, the idea is you have separate configurations per environment. So you have a complete Terraform configuration for network infrastructure and dev, production, UAT, and whatever else. And like with all decisions, there are advantages and disadvantages to choices. The good to this is that the code within each configuration is often simpler. It's easier to add and subtract capabilities per environment. And it does separate state if you're using the local file system default for state, which I recommend you don't do, and nobody really does anymore. The unfortunates about this pattern is that it has code duplication. Usually what will happen is each of these configurations, it violates dry, each of these configurations has code that's been copied, pasted from other environments. It's harder to establish new environments in this example. If I want to establish a performance environment, there's a lot more to copy, paste, change. And the worst part about this structure, to my mind, is it means that you're actually establishing, you're using separate automation for each environment, which means that environments can become consistent. The advantage of the first pattern I showed in the previous slide is it's literally the same automation that gets run in each environment, which we've all run into that problem where something works in dev or UAT, but it doesn't work in production. That's an example of environment consistency that we'd really like to avoid, and using the same automation for all environments really helps you do that. Then the question becomes, in environments, how do you make environment differences configurable? And you can use conditions. Terraform doesn't have an if-then capability, but what you do is you basically count on the, you use the count feature. In the upper right, I'm simply using a Boolean input private link indicator to indicate whether I want a private endpoint. If that's true, we create the private endpoint. If it's false, we don't. The count just indicates the number of times the resource iterates. You can also use Boolean indicators in dynamic blocks. I've got a client with some very manual procedures for DNS entries and other things that basically make it so that certain manual things have to happen after an asset is created before we can implement network rule sets in this case. So the Boolean secure resources basically indicates whether or not the dynamic block executes. And just to refresh your memory, dynamic blocks are a creature in Terraform where it will change your resource before the resource executes. So essentially what you need to do is dynamic blocks work on map inputs, and they only work on map inputs. So what I'm doing is converting that Boolean indicator into a map of one item that I don't use the values of, or being an empty map to get past that little quirk on dynamic blocks. Another feature that we use for optional configurations, if you're familiar with the Azure environment, if you define an app service, there's a site config option that has literally a couple dozen items on it. Basically, I don't want, in this case, it's a module, it's a reusable module, and I don't want consumers to have to list all 24 attributes for the site configuration, even though they only might care about one or two. So I use the try function. Basically what the try function does is in this case, let's take the always on line. It tries to interrogate a always on field in the object that's being passed to it. If it finds it, it uses it. If it doesn't, it uses null. And in this case, it'll find it, but it won't find the app command line or the health check path. Null in Terraform basically defers the selection of the default to either the Terraform cloud provider or even the cloud vendor itself. I don't want to get into the business of trying to superimpose my own defaults for things. Environment management best practices. We use CI/CD tooling such as Jenkins or Bamboo or Azure DevOps or whatever you use, or we use Terraform Cloud if our client has selected that. We do not run Terraform configurations from our laptops, except possibly in a sandbox environment when we're initially developing something. The benefits are you get audit history. Basically, you can tell who ran what when. If something's no longer working, you have history, and you can find out what happened when. You get a consistent runtime environment. You've got a consistent way to enforce Terraform version control. We always require a plan before the apply. We always require an approval step before going on to that apply. It's best practice to review the plan. Utilize cloud security constructs. When we run Terraform, we typically do so from the cloud. And we can use, on the AWS side, we can use IAM instance roles to give capabilities to Jenkins agents, and we can use managed identities on the Azure side to do the same thing. it gets us out of dealing with cloud credentials in the cloud credentials, at least on the cloud side. Let's talk about making your Terraform more reusable and easy to share between configurations. But first, let's talk about evolution. In the beginning, don't assume more complexity than you need. If in the beginning you only have one or two people configuring your Terraform enterprise-wide, use source control, use backend state from the beginning, but additional complexity is not normally necessary. As the number of coders grow, DevOps discipline gets a front seat at the table, and we get into feature branching, which we're going to cover, and CI/CD pipelines, which we already kind of covered a little bit. As the number of Terraform configurations go. Now remember, Terraform configurations are the outer Terraform project that you execute to create and manage infrastructure. As your configurations grow, the number of them grow, your number of modules are also going to grow. So what ends up happening, at some point you end up with a separate repo for modules instead of doing something local, or you use the Terraform registry, one of the two. And we implement module versioning. For any module that we refer to in a configuration, we never default to main. We never use main or master. We explicitly specify versions. We're going to talk about that. Feature branching. Basically, this concept is when I make a change to a configuration or a module, I create a feature branch, I make my targeted change, I do testing in a sandbox environment, and then I issue a pull request to get it merged into master. And typically, I'll arrange it so that there's a peer review that happens before that pull request is completed. The key to feature branching is that feature branches should live less than a day. Most of my feature branches live less than 4 business hours. And they contain single targeted enhancement. I've seen some people say, well, you know, I'm in here anyway, so I'm going to add 2 or 3 or 4 things to this feature branch. And that only increases the length of time that it lives, and it increases the probability that you're going to have merge conflicts eventually when you want to bring it back in. So keep your feature branches single and targeted and short. CI/CD pipelines, we've talked about some of this stuff. The main point I want to get across is I force plan execution in the pipeline, and then I force manual approval before that plan is applied or destroyed. In other words, before you make any changes. And in higher level environments, it's not unusual to have multiple approvals required before you apply or destroy. Out of convenience, I've seen some customers do an automatic apply, and that literally just nullifies the benefit of doing a plan whatsoever. Modularity, I'm going to cover that with coming from anti-patterns. And so I've got a series of anti-patterns I've seen clients or customers use over the years, and we're going to go through them and describe what you should do. One of the chief things that I see is module creation before it's needed. The build it and they will come kind of methodology never seems to work. YAGNI, basically it implements the YAGNI. You should have at least 2 consumers before a module is created. One of the reasons that my team does this is it's hard to track down consumers after release, particularly if you break modules out into separate repos. What ends up happening is module pollution if you do that. So we make sure most of our modules That code usually originates in a Terraform configuration, and we need to do a second configuration somewhere, and we recognize that we've been doing this before. So we'll go back to the first configuration, factor that up into a module, and then use it in a second configuration. Is generally the life cycle. But you really don't want module pollution. It becomes hard to manage, and as consumers, it becomes hard to find things that you may want to use. Honest to God, I've seen this. Modules that contain only one resource, such as the one in the upper right. The problem with this is there's no value add. It amounts to a thin proxy. So as a consumer, if I'm going to consume a module that's a thin proxy, I'm better off, it's probably quicker for me to consume the underlying Terraform resource. Basically, thin proxies are harder for people to consume, and they're usually not as well documented. So my team has a standard. Every module needs to have at least 2 resources to justify it being a module. Inappropriate data lookups in modules. All right, I see this all the time. The upper right has an example where an Azure resource group is looked up before a scale set is created. The problem with this is that if that resource group gets created by the configuration that's using that module, it won't exist at the time of lookup, and Terraform fails if something's not found. So you put this in a module, and it's a recipe for something that won't even plan. What to do instead is, in the case of modules, pass everything the module needs as a variable. Don't make the module go look it up. Now, Terraform configurations, the outer layer Terraform, it does understand context, and it can use data lookups, and should make use of that if it's appropriate. Undocumented modules. The example on the right was literally from our field experience. It forces the consumers to essentially audit the module source code before they can use it. Makes it hard to use. In my mind, modules should always have a README, and at the very top should be an example module call that a consumer can copy, paste, change very easily. Release notes. We're going to talk about versioning modules in just a minute. But each new version of a module needs to contain instructions on how to consume the new version. If it's a breaking change, output variable and variable lists and output lists, including what's required and what's not, should be in the README. Modules referencing main and manual, main or master. There's a recipe for unplanned work. Essentially, what happens if you consume master and somebody makes a change to it, at some point your configurations will stop working. And at that point, it's unplanned work, and usually happens at the most inopportune time. When my team consumes modules, we always consume a specific version of it, either basically a tag, or in the case of registry, a specific version number. And we always version our modules that we publish. And what that means is if we need to consume a new version to get a new feature, we can go do that, but it's planned work. Somebody gets a story, somebody works on that. It's not unplanned work. All right. So let's talk about a couple of final points. I call this the hammer and the nail problem. Some of our customers have got good at Terraform and decided to use Terraform for everything. Terraform is incredibly good. I love Terraform. I code Terraform pretty much every day, but Terraform is good for creating cloud assets or changing attributes or specifics on those cloud assets. It is not good for maintaining content on those cloud assets. So for instance, virtual machine or instance configuration management, If you've got a mutable infrastructure, use Ansible, Chef, or Puppet for that. Don't try to use Terraform for that. It's a poor tool. And don't try to use Terraform to remote control Ansible or Chef or Puppet into doing that. That's like hitting a bank shot in pool. Image pipelines. We use Packer. We don't try to remote control Packer through Terraform. Packer is another HashiCorp product that specializes in image production. But basically, the bottom line is use Terraform for what it's good for, but it shouldn't be the only tool in your tool set. And basically, not to diminish Q&A. I'm going to skip the session summary slide. Thanks for coming. We're going to do Q&A in just a second. But if I don't get to answer every question in Q&A, you can always contact me outside this talk, and I'll certainly get your questions answered. Good luck at the conference, and let's segue to Q&A.